Okay. All right, and we're back, and now I'm recording. Okay. All right, I can't wait to look through some of the stuff that you're posting. I really like seeing what you're interested in learning, or where you're getting stuck, or maybe what you're finding super cool about Unreal and how really powerful and pretty this engine can be. So how did it go? How did the static mesh pipeline stuff go? You feeling pretty good about that? Easy peasy, or oh no, Andre. Anything specific? You could give me some feedback. Was this something you were having a hard time understanding, or were you just worried that your models weren't coming out good? Or
I have a noob question.
I like noob questions.
So I'm importing from Maya, and it wasn't putting, like, I don't know how to put multiple textures in Maya anymore. Like, okay. I don't know if I ever learned that. So I couldn't figure out how to do it or find a tutorial. So when I pulled stuff in to Unreal, I only had like the color. Mm-hmm. And so I was like, well, I guess that'll be my material instance.
That's fine.
And it was kind of wonky even then. And I was like, I don't think this is working. So I went in to Unreal and I made it manually, the material instances. And so whatever, it's like, whatever, I tried.
That's fine. So the fastest way to make new material IDs on a single mesh is to have those meshes be separate objects first when you create materials for them, and then collapse them. And it will create multiple material IDs for the one export. Which is what I did with the boat. There are other ways to add material IDs that are a little bit more advanced, but that's not most of the time very necessary, unless you're doing more advanced techniques like lighting builds and stuff. So if you have one map for your mesh, that's fine. That's actually fine. I just wanted you to put a material instance on it that's referencing a master material so that you just know how to make it. That's what I'm most interested in. Okay. So did that work okay?
Yes. I think.
Okay.
I don't think mine was actually like referencing it. So I didn't really get how to do that.
Okay.
So I was like, I guess I'm getting lost here.
Okay. Maybe we can talk about that. We've got a couple of other comments. Andre just feels bad about it. I'm sorry.
Because I couldn't figure out how to add the textures into like a Unreal Engine.
You forgot how to add them in there?
No, I was like, it was in the last, like, I think 10 minutes. I was trying to figure this out, and I kind of panicked. So I just like threw it into the file and just turned it in immediately.
Perfect.
I couldn't import the model into Unreal, but I just couldn't figure out to get the textures at the last minute.
You can resubmit. You can just resubmit. And if you want, I'll hold off grading for like a couple of days on you.
Okay, perfect.
Rather do, okay, good. You were getting stuck on, were you getting stuck, or you just ran out of time?
Both.
Okay.
I ran out of time.
All right. So when I built lighting, it was dark on my models. That's possible that either the lighting you were using was really dark, or the materials were darker. I'd have to see, I think. And you gave me the project, so I could take a closer look at it. That makes me feel better. Oh, good. Also, Maya has different names, which don't usually translate. I didn't use Arnold, though, which I think is what we used in DMA 116. Yes, in 116, back in the day, we were teaching Arnold, which is a plugin into Maya for pre-rendered stuff. We're doing real-time rendering now, which is like a game engine rendering, so it's a little bit different. But Arnold does work similarly to how the material editors are in Unreal, and even in some cases in Unity. So I guess you got confused about the names of things in Arnold. Honor? Or, oh, you might still be writing. I'm sorry. Yeah, so Blinn and Lambert. Oh, those are the types of shaders. Didn't translate over to Unreal without adding pictures for textures? Right, no, the shaders are not going to transfer over. The material IDs and the mesh data will, though, because the shader is being operated by the editor itself. Unreal has its own shaders. And they do, I think the default is a Blinn, I think by default. So roughness wasn't an option in Maya. That's okay. That's okay, because you could reset up that material in Unreal. Like, it doesn't have to be a one-to-one transfer. So like part of what you're discussing is solved with some Maya plugins, like Maya to Unreal plugins that you can do, where you can set it up like it would be in Unreal and then just pop it on over. Or that requires some installs and stuff, and we're not gonna do that. But they do exist. Yeah. Let's see what we've got here. That was Honor's question. Even when I turned the skybox environment off, it still showed up in the render. Not a big deal, but it was frustrating. Oh, okay. So when you turn it off, Anna, I think what happened is you probably just unclicked it. Is that right?
Yeah, the like eye thing. Yeah.
That is how you turn stuff off in Unity.
Yeah.
So in the details tab, if you go down, there's a click where you could click disable.
Okay.
And that shuts it off. The clicking it off just hides it, and it will continue to render. Yeah, but that's a good question.
Easy
and a good
fix, though.
find.
That's good. Yeah.
I'm sorry.
Thanks.
I'm sorry. I'm upgrading you guys on lighting, so you're okay there. You're a-okay in that respect. Did some of these questions or answers help you feel a little bit better anyway about the grade? What I'm really looking for is your mesh setup and the material instance. I think I ran into that one, the skybox thing. Yeah, I want to turn the skybox off. You can remove it, make a new one, or you could disable it completely, and you have to do that in the details tab. And maybe I can find that when we're in there in the nitty gritty. I am going to go ahead and turn on Unreal. Yes, please, and thank you. For today, materials and real-time rendering, we're going to talk a little bit more deeply about materials. I've got a presentation and an example materials that we can use in class if you'd like to. You don't have to use this for your assignment or anything, but I do think it's a cool project that has some good, decent examples in here. Let me get my stuff. Let me get my ducks lined up. All right. And Unreal Epic. I want you to launch. You take a million years. Also, what else? I'm missing one thing. Right. Let me move this over here. I'll just download it over here. I am going to be grabbing that file also, but this one's going to be more. Downloading stuff. You may want to start your downloads if you want these projects and you're trying to follow along in class. What is that? I don't know, but we're going to open a new one. Actually, I'm going to finish downloading this. It's still thinking, so I'll let it finish downloading. Yeah, okay. All right, so let's talk about materials today. We're going to talk about this in a little bit more detail and in a little bit more depth. For those of you that have some experience in making materials and having just made 3D a little bit more than some others, I want to apologize a little bit. This is going to feel like a refresher for you, but I've got some folks here who haven't finished the 216 path yet. So this does require a little bit of review. So apologies there. All right, so we're going to talk about real-time material concepts, specifically what is, I need the refresher. Good. I feel like I always need a refresher. Just if it feels refreshing. Okay, I'm sorry. I'll keep going. All right, we're going to talk about materials, specifically about real-time rendering. So let's go ahead and pop this over here. You can follow along if you like. We're all small 116 students at heart. Oh, 100%. 100%. To this day, I can't remember where stuff lives in Maya all the time. I'm so dependent on my own custom shelf because I don't want to learn it. I just want to add an edge loop and just call it a day. And I completely understand. Some people though really love memorizing where everything is. So real-time material concepts That reminds me of Maya in the labs. Yeah, for sure. I was looking for my shelf, so many buttons and so many softwares. So true. And one of the reasons why I like to tell students to maybe don't take 2 or 3 3D classes at once is because these are beastly programs and you're just taking in a lot. Like, you're training your hands to where they're moving and what to engage with your keyboards. You're remembering where things live. And also they behave differently from engine to engine. Like the 3D navigation in Unreal is a little different than it is in Maya. It might be hard to articulate specifically why, but like, no, I like it. Like Neo and the Matrix, good for you. But I panic when I don't know how fast something's going to take me to understand it, right? Why isn't the screen moving? I forgot to press a different key. Yeah, exactly. So, you know, I know that some of you, it's kind of too late. You're here, you're taking multiple classes. We're going to make the best of it. I promise. But yeah, like if you're learning new stuff, don't be too hard on yourself for not getting it. This is a lot to take in, even for one quarter or one class. So if you're taking in multiple, you're a rock star. You got this. It's probably going to be kind of hard. All right. So real-time material concepts, specifically, what are materials in Unreal, which we have a little bit of an understanding of at this point. We've played around with it, master material and material instance. Like, we know some of the behavior of making these things. And what is PBR specifically? Now, some of you will even have some understanding of this because we had exposure to it in previous classes. Yes. And I see you. I got to make sure that like I've got the chat up here so that like people who are like watching the recording will know why I'm commenting. Anywho, so quick breakdown about what materials are. It is essentially an asset applied to a mesh to control its visual look. We think of it as like the skin that goes on it or the paint that goes on it. But really it's supposed to interpret or create a rendering style and a series of commands really that reflect what the material that particular object is made of. And, you know, there are obvious, I'll say, exceptions to that in very stylized, you know, type of work where, you know, a glowing green potion might not be a real thing, but it is still supposed to communicate like a liquid or something magical or whatever. I like to think of that kind of stuff myself because it's the type of art I really like to make. But what we want to try to remember, though, is that it is trying to simulate real world calculations. It's trying to replicate how light hits a surface and how it scatters and creates this interpretation for us, or this art. In its simplest form, think of it as the paint with the various properties such as color and finish. I think that's a great way to think about it. A material defines how light interacts with the surface it is applied to. Now, some of you might know the answer to this, but do you know what rendering means? The word? If you've had me before, you may know. Really? Don't remember? That's okay. So it's a big word. It is a big word. Render. The word render, right? It's a word. It means something. Most of you are probably like, it's the button I hit to make the PNG. It's the button I hit to make the dot movie file, the dot MP4, right? It's the thing that the thing spits out so I can turn in my homework, right? And you're kind of right. Rendering or image synthesis is the process of generating photorealistic or non-photorealistic images from 2D or 3D model by means of computer program. It sounds like you copied and pasted that bullshit from Google and you wrong, son. Ooh, I'm kidding. Actually, you're not wrong, but that is what the word has become. And originally the word, and this is the cool thing about this, is I like to remember where we get these words from. It is to communicate light on form. And it is what master painters would do. And it was the word that they would use when talking to each other. Yes, I like how you rendered her nose. It's very, very regal. What they're talking about is how they like how you shaded the form to communicate depth, light, and volume. And this is the stuff that painters did. And we would take, I say, I'm not a master painter, but we would take hours rendering that light. Well, then computer programmers showed up to make computer graphics for us. And, you know, just cause they made a button to call render, because essentially what they're doing is they're creating math to do that for us through simulation. Now, at first, we're using things like linear lighting concepts. I'm not going to like go into the science and math about linear and quadratic light fall off and all that stuff. That's future us problem. But know that, oh, so what used to be something that people did with their eyes and hands with paint is now something that's automated through computers using a series of formulas. So the render part means to communicate light. We're engaging with rendering almost all the time, anytime there's a camera. However, sometimes you might see something called unlit, and that is not rendered. It is displaying the image before any lighting information is rendered, including shadows and lighting and fall off and that. I used the word render in art one time, and my teacher praised the use of the word. Now I see why. 100%. That's correct. So like it used to be a form of like high level art concept and high level art skill. And it still is. You just have a button that does it for you now. You lucky duckies. I don't know why I said that like it's you, because I also use it too. In other words, materials are essentially the output of that light hitting surface and what it does to that. Material properties are usually what changes those outputs, like rough material properties, metallic properties that will reflect light differently. And we can kind of go into the science of light, but why? Not right now. Later. For now, PBR is a type of material that we use in real-time rendering, and it's going to show up in not real-time rendering as well. But it's used mostly in games and real-time camera work, like architectural visualizations, things like that. Unified lighting and shading system. It better approximates the better approximation of light and materials, physical interaction, intuitive and consistent. Yeah, I like all of these bullet points because they're all true. PBR stands for physics-based rendering. It's basing the rendering off of real physics and real-world parameters. Computers did not always do this for us. When I say computers, we didn't always have PBR. I mean, it was even like 5-6 years ago before it started to really affect the mainstream of our pipeline. Before, we would have to eyeball and approximate how metal behaves with light. And so some of us old artists, like your favorite 3D teacher, Neho, had to remember the warmth and cool colors that metals had. For example, steel and lead, they have cooler colors in the reflection of the metal. So it's usually kind of a dark, like gray color with a really soft light blue. Silver is slightly warmer. Copper, you pretty much know the color of copper. It's the part that you see is that bright orange, like rosy hue, and so on and so on. But now we've got things that will actually calculate those for us without having to approximate with our eyeballs anymore. And those are PBR renderers. Substance painter, substance designer, all of that is basically doing that for us. No, this is actually kind of cool. Besides Unreal's PBR system being based off of Disney and Pixar's foundations, which is very cool, it removes a lot of the guesswork by creating parameters based on scientific law, such as conservation of energy and inverse square law. No, you don't have to know what that is, but I still linked them here for all you nerds that might want to learn. So you're welcome to check that out if you'd like to. Like, oh, so interesting. But we won't have to cover all that right now, because as artists, we don't really have to be scientists. I think it's cool and inspiring. Okay. Now, real-time material concepts. Here's some additional documentation provided to us by Unreal. Can you go to there, please, so you can see? It's a further breakdown of the material pipeline. If you prefer to read rather than watch videos and such, you can take a look down here on a far more intricate, detailed breakdown. This stuff will get you pretty well versed on it, but it's pretty dry. No, I'm not going to quiz you or anything on it, but I do like to share the content, so you do have access to some more documentation if you would like. And now we're going to talk about the primary nodes and textures that go into these materials. Now, at the moment, you are working off of memory. You're remembering that we talked about some of this in previous classes, and you're throwing these textures into Material Editor to make it look good. And you maybe don't remember what everything is and does, and that's okay, because we're going to refresh it right now. Primary nodes and textures. We're going to talk about the primary PBR inputs, which is what you've mostly been working with up to this point. Some material settings and texture settings within Unreal. Here, primary nodes, textures. Before we kind of go into this, these are going to be the maps that we'll talk about today. Probably not normal in detail. We'll add a normal map. But we're going to go into more detail with the color-based, metallic, specular roughness and how it relates to Unreal. So first thing I want to do is I want to open up my my project. So give me a second. I have to open things. I want it to be ready and I'm not ready, and I don't know how to handle awkward silences very well.
I think I saw that online.
Yeah. Intro. Mat 101. This guy. Maps. This is what I was looking for. Okay, maybe we're fine. Maybe I'm crazy. Yeah, I'm fine. It's fine. I'm fine. Okay, I don't know what happened there. I don't know what I missed, but all right, we're looking okay. Maybe I just downloaded the wrong thing or something. Woo, yeah. So, all right, looks like we're a little bit more back in business. Sorry about the delay, everyone. I'll be sure to cut that out of our final video, so you don't have to sit there and wait through it if you need to review this again. Okay, so what I want to talk about, first off, first thing I want to do is stop that annoying grid flicker. You know what I mean? Do you see it? I'm going to turn it off. You can turn it off by hitting the letter G. And what that does is it toggles in and out of what they call game mode. So we've got like all of the icons are on, and including the grid. If you just hit G, it turns all that off, and we've got kind of just we could still interact. G for go away. That's right. So we can still like interact with the space without the icons. You want the icons back, which can be helpful when looking at lighting. You could just toggle that on with G, you know? One of the reasons why I really wanted to share this project with you, though, is because look at this. Look at how much fun is going on here. Many of you have had in the past questions about getting effects like this, and I wanted to share it with you so that you could see a little bit more how constructed they are, like within, and how powerful this engine can get. We can take a closer look at that after we're done with our material demo, because once I show you a little bit more about how the material editor works, you're going to be more informed about how that works. That's my goal anyway. So let's talk about this guy. By talking about it, really what I want to do is I want to open up the material editor. We can do this a few ways. Sorry that the chat is covering the world outliner. I feel like that's probably the least important thing that you need to deal with while we're doing this demo. Maybe I should just also hide my face too. There we go. And also, I'm going to turn on my keyboard so you can see. Yeah. Okay, so you can apply materials. You can apply materials, as you know, I believe, by finding them in the... that's also kind of annoying. Whoop. There we go. By finding them in the content browser and dragging them onto an object. Now, when I've got this over here, we're looking at this particular statue, this material ball, and I look at the details. I can scroll down to a few things. One of the things that I want to show you is here we go. You can find the materials here. This is named Master Material Complete. Master Material. You can find it by typing it in, clicking there. If you hit the little that thing, search Magnifying glass. That's it. It will find it in the content browser for you. So you don't necessarily have to type it over here if it's over here. Or you could say, I want to find the master material. It'll pop it up here, and then you can click and drag it into the spaces here. Or again, like you like to do, click and drag it right onto an object, right? So that's kind of fun. Multiple ways to apply materials to the object. I think we were pretty comfortable with that. I'm going to open this guy up and we're going to take a closer look at how he's constructed. This feels like there's a lot going on. And you're not wrong. There's some information happening here. But I want to focus for now on this guy. This right here. What this is offering is essentially the shader, right? These are the slots that the shader supports. Changing shaders is not something you'll have to worry about doing right now. But this is the part where I think you were probably getting a little hung up on Honor. Like it doesn't have the same slot as you're right. But this is going to be their final output. So maybe creating a roughness map in Maya might not have made a lot of sense, but you know what would have? Doing it in Substance, like a Substance Painter or Substance Designer, like could just spit out the roughness map so we could plug it in here. Now, you can click these nodes and click and drag, and you'll notice that we've got these little noodles coming out of them. Officially, I believe they're called connectors. But you call them noodles and call them wires. Those have been called that by people who work in the field, and that's okay. Officially, though, I do believe they're called wires or connectors. Excuse me. I want to talk about a few different areas here. You see the grid. We're familiar with the grid. There's a bunch of stuff happening up here, and we're probably not sure about most of it. I'll cover a few of them. The save and the apply and their relationship here. So what you should know first, turn that off. What you should learn first is that the apply will apply changes that you've made in here to the rest of the project without saving it. And why anybody would want to do that is usually because you're not sure you want to commit it everywhere. You just wanted to see what it looked like in the scene before you make any kind of commitment. So that's what apply does. But you'll notice that this little apply button is not going to be green unless you've made a change. Now, I didn't really make a significant one, but like just to be clear, it will show up when I here we go. Just by like moving a node. Moving a node is enough for it to say like, you wanna? Saving it, we'll save and compile the material for the whole project. And you know, whether or not you want to adopt that in your workflow is entirely up to you. I do on occasion. Can you please save it? What? Stop all assets and return to editor? I'm sure that nothing is wrong. Cool. Oh dear. So because I'm starting to get bugs now. I'm getting concerned that you guys have the same problem. Okay. Browse. The browse button, it's the same thing as basically the magnifying glass anywhere. If you have an asset open and you click browse, it will find it for you in the content browser. So if I'm back over here and we have no idea where it is, I click browse, it'll just go right to it for us. That's super handy. You know, that's a very cool thing that can happen for us. Let's make sure. Search is what it sounds like. You can search for nodes that you've created in your material if you want to find them. Albedo, everything that has albedo will come up here. I don't use it often because my materials don't kind of get that wild, but they certainly can. But it's a pretty handy tool nonetheless. The cleanup. Home. Home is cool. Oh no. I'm zoomed way out and moved over. What do I do? How do I find it? I can't zoom out any further. We click home. Whoop. It'll center us right back on our home node, this guy, and put us to 1:1 on our zoom, which you can't see because I've got zoom covering the zoom. Neat. Let's pop that down there. At the very top right corner, you can see a ratio of how far in or out we're zoomed in. Woo-hoo. And if we hit home, it'll set us to 1 and pop us right here in the middle. That's also very handy. Cleanup. I want to show you what cleanup does. Let's say I've got some stuff floating around here. I don't know, just adding some nodes, and I'm using them and I'm making them and stuff. And I've got these other ones here I wanted to try. I want to swap them out. And I decided that I don't want them anymore. I'm not going to use them. You can select them and delete them, which will do it for you. Or if you click cleanup, it'll remove any nodes that are not in using a connector, that are not connected to anything. That's handy. I don't use it very often because I usually just delete as I go, but some people are like, they work differently than I do. And that's a handy tool. The connectors are the connectors feature. What this is going to do is it's only, you can say, I'm only going to show me what's being connected. I don't want to see anything else. I don't love that because I feel like I'm constricted. Like I don't know. I thought this looks different. So if you see this and you want to see this, that's why. It's just hiding everything that isn't being used at all. So live preview, I never turn it off. That's essentially this guy, meaning it will constantly update right over here as long as I wanted to. You can turn it off, make changes, and then not see the live update if you want to. I think the only real reason that you might want to do something like that is to maybe save in processing or save in like your graphics card. Like I'm having a really hard time. It's having a hard time keeping up. So you might turn that off. But practically speaking, I can't imagine you not wanting to see the changes that you've applied to it. But nevertheless, it is there. I won't worry about live update or live nodes for now. Hide unrelated is kind of nice. So if I have hide unrelated on and I select a node, it will show me the noodle and only the noodle that it's affecting. That is super, actually really handy, especially as things get a little wily and you want to see where they're going. You can get a quick visual of that. I won't leave it on right now because we're going to be going through some stuff and yeah. Stats. The stats stuff is it's helpful for us as we learn more about this, but we won't really need to worry about it now. And I think we're pretty good over here. We're likely to not use the preview nodes or the hierarchy at all. But yeah, I wanted to kind of cover what some of these do up here because we're going to start creating materials and editing them in a little bit more detail and in more depth. Now, this feels like there's a lot going on, and you're right. There's a lot going on. For now, just know that they're all doing some fancy math to create a really pretty output, a really, really interesting kind of result. The primary nodes that we'll talk about, which are the same that are in this material here, are going to be the albedo, metallic, specular, roughness, and we'll just plug in a normal for now. So we're not going to cover that. We couldn't cover it in class on Monday. So the albedo, this is color, just color, only color and nothing else. By default, you might have some reflection or reflectivity happening on your material, but that is not an albedo value. That's usually just a default setup that is happening. So like to be clear, this is only color. Flat color without specularity or shading. Linear RGB vector 3 value between 0 and 1. What does that mean? What does that mean right there? Anybody know? Anybody have an idea?
Is it like the opacity?
Okay, good attempt. So a vector 3 is a term in math. Now, like if you tried to Google it right now and we're like, what is a vector 3? What's a vector 3? Vector 3. Okay, calm down with that. Math. Math's for dummies. You need to decode it. Now, usually vector 3s are used specifically in 3D. I was hoping that maybe somebody would actually show a thing. Now, usually they're talking about the XYZ axes. By default, that's usually what things are meant when we're talking about 3D. But we're talking about materials. So how come a linear vector 3 values between 0 and 1 could have anything to do with RGB?
RGB is the the 3 points. Red, green, blue.
Red, green, blue. That's right.
XYZ.
Yes. Linear red, green, blue, or vector 3 values between 0 and 1. Vector 3 looks like something like this. Now, like, people are probably like, hold the phone, Neho. What do you mean you are showing us math? Oop. Oops. In code, it looks something like that. We've got like a space for 3 values in between them, right? So if we were going to look at, let's look at new. Sure. I don't care. This is fine. Let's look at a color of whatever we want. Boom. Okay, great. I did it. I got color in here. Now, our channels for red, green, and blue are as such. I've got red, green, and blue, right? But why are the values, why are red, green, and blue gray? If this is an RGB output.
Oh, do you only draw in red?
Right. Okay. Right. The channels here, what's being put out here, we know that it's red falling off to like white. We intellectually know that. We're artists. We know colors, right? Blue. Let's look at red. Let's look at red right here. If white is yay red and black, or sorry, white is yay value and black is no value, then from this area here, this is how much blue is present. Less blue in the middle, more blue in the white. Same thing with green. Less green in the middle, more green in the white. Red, though, whoa, red is like still a lot of value here, less, but whoop, here. So what's happening is it's adding all of these values to give us our final output. And it's doing it linearly because that's our grayscale. Now, I actually kind of want to talk about math for a few more seconds. I'm so sorry. I think I'm going to bring you over to my Cintiq, though, to do this. Come over here with me to my Cintiq. Okay, so if we come over here, I'm going to remove that. I want a flat color now so that we can talk. So we can talk serious. All right. Woo. All right. So we're going to talk about a couple things. I would like to talk about types of data. Okay. We're going to talk about, oh no, did my Cintiq stop working? I'm having all of the technical difficulties today. What is happening? Oh my God. One more time. Okay, we're back in business. Sorry about that. We're going to talk about a couple of different types of data. Okay, so it's going to sound a little bit familiar if you're interested in programming at all. Sorry, did you guys hear them? Did you guys hear the boop bida boop?
Yeah.
Sorry, I was like, it's like when it takes disconnecting, connecting, disconnecting. I don't know. All right, so let's talk about a few. We're going to talk about Boolean. We're going to talk about ints, strings, floats, and I think that's plenty. I think that's all we need to talk about. Okay. All right. Does anybody know what these are? If you do, yay. If not, that's okay. You're not.
They're numbers.
They're numbers. Most of them are numbers, except for this guy.
Whoops.
Yeah, but you're right. And that's actually the only reason I brought in string is to differentiate between number and a character of a number. So, like, since you pointed that out, right? Strings are just characters. Meaning if there is a, a field for typing anything in, what they're basically saying is that whatever you type in here, it only means the symbol. We're not adding anything together. So your name could be Charles III and you use the 3 and it's not activating that 3 is a value they're going to do anything with. So, I heard it again too. Oh no. Oh no. You know, that's fine. It just means that Neho needs a new Cintiq. That's all that means. I just need a new one. Oh no. Oh no. Worst. Okay. But you're right about these guys. So let's cross out strings since we don't need to worry about them anymore. We know that that's just means letters and characters and stuff. But Booleans, ints, and floats, they are numbers. Do we know the difference of the type of number that they are? No? It's okay. Let's start with int. These are whole numbers. Whole numbers, meaning you can only use 1, 2, 3, 5, only whole numbers, nothing in the middle. No 1.5, just whole numbers. You probably won't use this too much unless you're going to be writing code, but every now and then you might need a whole value of something. Won't worry about that right now, but integer means that this character I'm using is a number, and I need you to use it as a number. Thanks, program. So now we've covered that. Booleans and floats, though, these are going to be some of our buddies. We are going to talk to them a little bit. What's a Boolean? Anybody? It's okay. It is either or. 0 or 1. True or false. Usually represented as a 0 or 1. Anytime you see a checkbox that is not checked, it's a Boolean that's set to false. And if you click it, it's set to true. Okay, so on, off, yes, no. That's it. Only yay or nay. Now, we've used Booleans in our materials. We're going to, especially next week. But for now, just know that there is no in between, no wiggle room. So we've got whole numbers for integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, or null. Boolean, 0 or 1. That's it. Nothing in between. And floats. I have a love-hate relationship with floats because I use them all the time, but the word float bothers me. I feel like it doesn't effectively describe what it does, but unfortunately for me, the world doesn't care about my opinion. So a float is essentially a number where you can use any varying value in between. So we'll say, for example, between 0 and 1, and you can have 0.5, 0.6, 0.55, and anything in the middle. So essentially, if we've got 0 and we've got 1, we've got what you could consider a little slider in between. Okay? So now, in visuals, the float is often represented in color. And for the Boolean, it's white and black. So can you guess what the float would be?
Gray?
Grayscale. That's right. So we've got black to white. So that's our float. That's Boolean. Black being 0, white being 1. Now, if we look at our channels again, and let me do maybe something that's a little less confusing, because I think the red might be throwing us for a loop. I'm going to delete that. Yes, please. I would like a new layer. Please. And I am going to white. Let's pick some colors. Red. Green. Blue. Okay, that's about as raw as we can get. Oh, how about I get black? I'm going to do black. Okay. All right. Now
Getting Super Nintendo vibes.
What's that?
Super Nintendo vibes.
I know, right? I know. Okay. Let's look at the blue channel. What did it do? It took our blue away. Why is that? Well, the reason is because white in light is all of the colors combined. Black is the absence of all of the colors. So if we look at the blue channel and just the blue channel, well, we've got a little bit of blue in the green where you can see how it's lighter than the rest of it. None in red and none in black. All right, so let's look at green. We've got the green went away. Is it making sense now? Just a little bit?
Yeah. So white is like 100%.
Yes, correct.
Okay.
And black is 0%. And we use grayscales to mix them. And now, like, we know too that, like, effectively, if we were going to put a color that takes multiple of our primaries here, and we were looking at something like orange, you know, that's a little bit hot for an orange. Let's look at yellow. You go, hey, listen to me. Do what I say. Oh, for goodness. There we go. Let's look at our channels this time. Now there's no blue and yellow, right? There's a little bit of green and a lot of red, right? So that is how they are combining these values. So let's come back over here. Coming back over to my stream. Okay. So here we are, back here. The linear RGB vector 3 values between 0 and 1 are creating the color value. That's what's happening here. Avoid pure black and pure white, as they don't really exist in nature, and that's true. Our eyes have not seen pure white or pure black. We've seen representatives of it. I mean, even when we're looking at our computers, we're looking at like a representative of pure black. But you're like, but I can close my eyes. Yeah, but you know what? Light's still coming through, still hitting your eyeballs, and it is also being mixed with the skin and color of your blood. And it is actually kind of more of a dark red. And even then, you're representing black with an idea, and then you can actually start to envision other things. So what's actually happening is that you are not really seeing pure black. But what if you were in a pure black room? Yes. And total voidness of all light, completely. Usually it only exists in like the blackness of space, right? That doesn't happen in nature, in our world. Like there's usually always light, even moonlight or whatever. I've got some stuff popping up. What do we have? Sounds amazing. I know, right? We can't see pure white either. Usually we see something that's kind of off a hue. Even the sun has warmth to it, has like a slight yellow tint to it. Pure whites, pure blacks don't often happen. Fun fact, and this is just going to be a little art nudge. If you look at the, actually come back over to my Cintiq. If you look at the color picker here, in this box here, usually, and you know what I'm gonna do? The colors, yeah, I'm gonna do a print screenshot. Just gimme. Let's put that there. Okay, we're looking at our guy here. Deselect, I want my marquee tool. So I'm gonna draw a little marquee tool here. This is affectionately called the Goldilocks zone, because anything outside of it is not typically colors that we see in nature, really. Not usually. You might see it on a computer screen, but we don't see it out in the world. So when you're making photorealistic stuff, you typically want to stay away from the outside of that box. Colors come back together and work in harmony the closer to gray they are. So usually that's why part of the reason a lot of photorealistic environments that we're used to seeing are desaturated. You know, your Call of Duties and your whatever war games and stuff. That's part of the reason why. If you close your eyes in a pitch black room, it will actually look lighter. That's true. That's so true. Isn't that weird? That would be cool to use those colors outside of that for like fantasy game or dream. Yeah, it's actually a great way to use it. Like use those colors for fantastical reasons. Like perhaps this particular potion is glowing in the dark because it's toxic, or you're making an alien thing, or it is a stylized choice, like it's a Steven Universe style universe. I say that because I love making stuff from like Cartoon Network. That's like my favorite stuff to do. So like the color itself, that's kind of a breakdown of color. It's just the color and nothing else. And that's part of the reason why they're saying stay away from pure blacks and whites. And they mean that in the vector 3. And that's why I highlighted that Goldilocks zone for you. All right, so let's keep going. Metallic, grayscale value that ranges from 0 to 1. What does that sound like? That sounds like a float, right? Most common usage is on or off, 1 or 0. Oh, okay. Most common use of metallic is either it is metal or it isn't. I agree that that's the case most of the time with most materials. Is if you're making plastics, they're going to kind of come over here. Leather will be over here. But if it's metal, it'll be over here. However, every now and then there's some exceptions, like pearl. Pearl is going to be something in the middle, but those are uncommon. So while it's not a never use, it's a most common use is either on or off, which is a Boolean. When on 1, it yields 100% specular reflection. So we get that specular gloss kind of shine to it. All right, now we're going to look at roughness. Grayscale value that ranges from 0 to 1. Ranges from smooth mirror-like surfaces at 0 to rougher matte surfaces at 1. So now we're talking roughness as a value. If it has 0 roughness, it is smooth, right? Total glossy. Ooh la la. Unlike metallic, you are encouraged to fine-tune the roughness value between 0 and 1 or use a texture to that effect. Yes, you're often going to want to adjust that a little bit more meticulously. I do it with all of them, honestly. I'm extra even with my metallic values, but that is mostly the case. Okay. Specularity. Grayscale value that ranges from 0 to 1. A good rule of thumb is to set the specular value to 0.5 and fine-tune the roughness value instead. Now, the roughness and metallic features are PBR plugins that I've now started to overcome specularity, because we used to actually create all that through the specular channels. Well, now we've got PBR setups that are giving us these other values, but we still have specularity. And what often happens is that it stacks on itself. We like to think of it as, I think, like a power up of those other two. So leaving specularity at like 0.5 as a rule of thumb is a great place to start. Getting your other maps there before doing anything to your specular map. Is that what you have to do? No, you can do whatever you want, but that's usually what we do in practice. In some cases, you may decide to edit the roughness value or use a bitmap to that effect. Bitmap is the texture file. Used to push stylized looks or over-the-top glossiness, not always needed with roughness value. Yeah. Okay. So, do you have any questions so far? You guys holding up okay? So we're covering a lot right now. Looking at, okay, all right, doing good. Like, let's keep on. Supported formats. We do need to talk a little bit about the types of images that you're using. What is supported by Unreal are these here, but maybe don't always use them. I did talk about that last time, I think. Targas are very cool, except you don't always need them, and you could probably just get away with an additional PNG anyway. But we could talk about that as you're starting to make more materials. PNGs is excellent. They are the preferred format, really. They're compressed, but they're not so compressed as a JPEG. For optimization purposes, it's best to work with PNG due to its lightweight file size and its ability to have transparency info when needed, which is what we used to use Targas for in the alpha channels. You still can, they are supported, but they're not used as often anymore. It's pretty much just PNG at this point. Please do not, even though it is supported as a format, use a Photoshop document. Photoshop documents, proprietary to Photoshop, are used for all of their layer data, all that layer stuff. Yes, it can open, but what you're doing whenever you do that is you're making Unreal reconfigure all of those layers so that it knows what to spit out. And that is a lot of extra compiling that you're asking it to do in addition to the materials that you're already compiling. So in the interest of optimization, do not use Photoshop documents or Illustrator files or anything that is kind of meant to be used in a different software. Next. Okay. Now, this is something I have talked about in previous classes. I'm going to say it again because it is this important. And I'm excited to talk about it because I even get to show you a bit of a visual about how it works and why it's so important, okay? So textures that you should use should always be a power of 2. Do you know what that means? What is a power of 2? What's a power of 2? I know we're talking about math, and it's all relevant. What's a power of 2? Nobody? 2, 4, 6, 8. Who do we appreciate? Yeah, that's right. 2, 4, 6, 8, 16. There we go. Then 32, right? Very good. Very, very good. My bad math is showing. Oops, that's okay. You don't actually have to do the math, Anna. So you're okay. But you do need to understand why we have to do it this way. So I'm gonna come over here. All right. So powers of 2 look like exactly what you were talking about. We've got 2, 4, 8, 16, 32, 64. Numbers are starting to look familiar, right? 128. What's the next one? What's the next one, my 3D kiddos? What's the next one? 256. Yeah. Anybody got the next one? 512. Okay. 10, 24, 20, 48, 40, 56, and 81, 92. Okay. That is how high the powers of 2 bitmaps or texture files that you'll use is supported in Unreal. But excuse me, Miss Neho, I've just used like 1000 by 1000 and it worked fine. Now you're right. It will work. Only now your art's going to look like pew pew. And I'm going to show you why. So first off, they need to be power of 2s so that a few reasons. One is memory. Okay. Every round up, we're starting at like a pixel. And remember what this is actually? It's not just one power of 2, it's by itself, right? These are 2 by 2 textures, 4 by 4, 8 by 8, 16 by 16, et cetera, et cetera. Okay. And the way that works is something called, I think like a texture pyramid. Actually, I have a visual in my thing. I don't have to draw it out for you. This will work. Boop. Right here. And notice how they get bigger and bigger, like scaled up, right? By half. If you give them a value in between, first off, the way computer memory works is that it duplicates on itself. So if you have something in between, like let's say you've got a 1024, and instead you're like, I'm going to do 1025, even 1 pixel more. It's going to put it in a slot that is large enough to hold a 2048. All of those pixels are now not being used. All of that memory is being occupied and not used to actually make your work look better, when you could be scaling up to that size and just have a higher resolution across the board. Okay. So that's like one reason not to do that, for obvious reasons. You're just like being like not very like frugal with your memory space. But then there's this other reason. MIP maps. Gosh, it's based off of the Latin term. I don't want to say large, like many in a small space. Actually, let me translate to English. The way many in a small space. No, not man in a small space. Oh my God, what is happening? Many, multi, in a small. Yeah, multa in parva. That's what it means. MIP, multa in parva. There we go. Multa in parva maps, meaning we're going to put many maps in a small space. Now, this is cool. This is cool. If you use a size that is not a value of 2, MIP maps will not be created. Unreal does it for you. MIP map. With and without. Let's look at it. Open. Yeah, this is good. An image in a new tab. See that? With MIP mapping, proper blurring as distance occurs. Without MIP mapping, your graphics card is trying to render each pixel and they're fighting with each other, even in faraway spaces. Because remember, this is not actually a 3D space. This is a 2D image that your camera is trying to create an illusion of depth. So it's trying to keep it tight, but they're fighting, and some are winning and some are not. And we're getting like this weird squiggles happening here. And who wins is kind of a random, which is why we've got missed patterns here. This doesn't make any sense, right? Okay, so all right, do that so it doesn't look bad. Now I'm going to show you on a visual that somebody shared with me, and I want you to see how Unreal automatically creates these mip maps for us. But it has to be streamed to do it. And so in order to have that, we need to make sure that our textures are always a value of 2. And then Unreal will do this automatically. Okay, let's present. Am I sharing audio? I believe I'm sharing audio. Good.
Map. This is a 1K texture. And it's a mip-mapped texture. And as we move away from it, we can see that it's updating in real time with a lower scale version of 512 texture, half a K, 256. These are all powers of 2. And this is happening with all of your texture maps in Unreal in real time. Not only does it happen with the whole map, but Unreal will calculate the map and utilize MIP values over a gradient of a surface. So this is a really powerful tool for ensuring that your textures look their best at all times, in real time, all the time. This is game engine thinking.
This is game engine thinking, guys. He's really excited about that. You can tell. So yes, to answer your question, Anna, it is similar or related to LODs. They are levels of detail. Now, we know like how high texture resolution maps look really great on our models, right? A 1024 is a pretty good number to start, even going to 2048 if you've got like a really fancy thing you're trying to show on a portfolio, you know, like look up close. But if you think about it, 2048, that might actually take up the resolution of a whole computer screen. And you've got a 3D model that is taking up maybe a third of the computer screen. So does it really make sense to have high resolution maps on objects far, far away that are taking up maybe 300 total pixels of your computer screen? And it needs to render 2000 on the whole model itself. Is MIP mapping like an on-off feature, or do we have to adjust it? No, it just does it. It's just automatic. But you have to have materials or texture maps based on a power of 2 for it to work. So did you see how it went from 1024 to 512 to 256, etc.? It needs those values. So if you have a high resolution texture map, it will create MIP maps for you. Like you don't have to do it. It just does it. Yeah, that's sick. Yeah. Okay. Woo! All right, importing textures, pretty straightforward. I believe somebody might have been kind of stuck on this one. Hope I don't need to save it, because it didn't. Woo! All right. Unreal. Let's take a look. We got our guy here. When you bring in materials or textures into the engine, I mean, you can just bring them in very easily by, you go import here into this folder, or you could find them on your computer and drag them on in. Oh my gosh, turn that off. You can drag them in. Once they are in here though, I do want to show you a couple more features. This is an Unreal cool thing, is that once you've got the materials in or the textures in, you can do some basic adjusting of the texture map within here. Let's go to adjustments. This is really what I want to look at. Oh, and this part up here. And of course I've got my zoom a little high here at the very top though. We've got imported 4096 is that texture. Streamed. It created 13 MIP maps, meaning there are 13 layers of levels of detail of it going farther away. That's how you can tell once you've popped in a texture map, you can look at the details of it It's just simply by like double clicking it in the project. We've got this window and you can see here, bitmaps 13. If you put in something that's like 500 by 500, it will be not streamed and there will only be one. So that's how we know if it came in correctly. Compression settings, don't worry about this right now. We don't have to worry about that right now. And also we've got the Zoom chat kind of in the way at the moment. I should just move my face. You guys don't need to see my face. We could just do this. I'll turn the Zoom up. But adjustments though. Adjustments right here. This is kind of cool because we can have some kind of basic, oh my goodness, zoom out please. Thank you. I'm gonna have some basic simple adjustments here. I can make it brighter. I can give it a color pass, change the hue and create basically a different texture if I wanted to. I can't come in here and like paint or anything, but we can make a few adjustments. Say if I wanted to make it a little bit brighter, it's going to take a second to catch up because my computer's doing a lot right now. Ooh-wee. Okay, so it's a little brighter. I can make it adjust the brightness curve. Let's see what that does. Okay, I made it darker actually. I'm going to set that to default. I'd like to increase the saturation. So I'll just stick with that as my last showing you of how this works. It does take a second for my computer while I'm running, you know, OBS and streaming and Unreal and all this stuff. But you did notice too, as I made changes, these little yellow arrows popped up. These are cool. And you'll see them throughout. But basically, these are just, hey, go back to default for me. And you just kind of start over. I like those buttons. They are very friendly. They help me kind of get back to a normal space. I'm like, oh, I made all these changes. I don't know what. But I can put it back to default. We can save it and turn it down. So texture maps, we got to be power of 2. Now we know why. And now let's look at some of these materials or some of this stuff here. This looks like a lot, but I'm going to cover it. I'm going to actually close this out. Would you like to apply the changes? No, I don't want to do that. I'm going to make a new one. New material. This is going to be the master start. I'm just going to make a new one, but we're going to like kind of recreate the one that's right there. All right, so how to bring these in? I believe somebody had a question about that. Well, we could just kind of click all the ones that we want, which are all of these or none of these. But I'm going to bring in albedo, AO, normal, and roughness. Remember to name them something that you'll recognize, which is why you want to commit to your own naming convention. Just going to click them and drag them into the material. Just the material editor. It thinks really hard. Oh, you know what I could do? Turn off Photoshop. I'm not using that no more. I don't need that anymore. That'll probably help me. All right, so here they all are. Now remember, we're going to be making a master material, so these do have to be parameters eventually. They are not parameters when I pop them in here, but that's okay. We could still work with it as we build the material to be what we want it to be, right? Okay. Anybody have any questions so far? Because that was one of the things that I think somebody got stuck on, and I just want to make sure that you've got, you know how. Okay. All right. Don't worry about it. Cool. So now what I've got here, I've got some stuff, and what you've been doing in the past, and that's okay, is that you've been like, I'm gonna put the base normal, or I got beautiful color. Is it thinking? Here we go. Color. Did it. You're right. And that's sufficient if your maps, as they've come in here, are exactly as you want them to be, which is rarely the case, because they might look a very specific way in Substance or in Maya or whatever. And something about the lighting here is making it look a little darker or a little lighter or something. It's safe now. That's fine. Right? Okay. So what I'm going to do is I'm going to undo that. I hit control click to like detach it. All right, so what I'm gonna do now, does anybody actually need to take a break? I've been kind of going at this for a while now that I think about it. Does anyone want to take like 10 minutes? I'm good to keep going. Okay. Okay. Andre said you do want to take a break? Yeah? Yep. Okay. Let's take like a 10-minute break. Won't be long. And then I will show you how to plug in and do some of these cool, fancier things in the material editor. Just to get you started. Okay. All right. 10 minutes. We'll get started at, we'll make it 12 minutes. 2:10. All right. So, let's talk about some of this. First thing I want to do is I want to talk about, parameters and expressions and math and things. Like, it's pretty clear now that, make sure I'm actually recording. Yes, I am. Okay. It's pretty clear now that we can't escape that math is a part of this, and we will have to talk to math. But what we don't have to do is we don't have to like add anything together. We don't need to like do equations in our head or anything like that. But our understanding of how that works is definitely going to help inform what our decisions will become, right? So we know now that grayscale is effectively a floating point integer. It is a float. It is a scale between 0 and 1 communicated through a value of gray to black or white to black. And so it is that we use the numbers of those channels, RGB, and we do stuff to them to spit out a new value, right? So the first thing I'm gonna talk about is add. Addition, easy peasy stuff, right? So I'm gonna hit A. Well, let me turn on my where is it? Is it not on? Oh, it's right there. Never mind. So that way you can see what I'm hitting. Hold down A, left click onto the grid. And it gives me an add expression or an add operator. Now, in a mathematic equation, the plus signs, minus signs, those are called operators. Multiplication, division, operators. That's what this guy is. An expression is a whole thing. So what we're going to be doing is we're going to be creating expressions, and there might be expressions we'll use within it too. But for now, just know that we're going to do add, and I want to click and drag the RGB into add. Now, what are we adding it to? We haven't really added anything to it. It's just nothing, right? Well, okay, so we could create another parameter or another value. And since we know that RGB is a vector 3, we could use a vector 3 value. Now, like vector 1 is like an integer, just one number. 2 is 2 numbers, and 3 is 3 numbers. And we know that RGB translates to that sort of XYZ value 1, 2, 3. So to get the vector 3 parameter here, if I hit 3 and hit click, I've got the parameter right here, or the expression, excuse me, the constant. It's a constant, my bad. And I can click and drag that puppy right on over. Now that was actually kind of interesting. Can I undo that? Yes. By holding down Alt and clicking, it removes it. If you hold down Control and click, it detaches it and lets me attach it again. So, before I do that, I'm going to click and drag and see as I hover over B, my cursor shows a little check mark. The check mark is telling me, yes, you can do this. So I'm going to click it there. And right now I've got black as my default. My default constant. Okay, cool. What happens when you add 0 to any number? What's the output? Guys, what's 1 plus 0? This is not a trick one. You got this. 1. Great. What's 12 plus 0? Right. So I'm adding 0 to it, meaning it changes nothing. I could, by clicking the expression here, I could put start previewing node. And what it'll do is it'll update live in my preview node here, just the color value or anything that we're doing to it. So this is what it looks like without any value to it. If I wanted to change this, I could start adding value to the red, blue, and green channels. And let's say I just do something like 0.5 across the board. All right, so we add a grayscale to it. It is going to add 0.5 to every channel in here. And now it's like super light. Oh my goodness, that is like really light. Let's tone that down. Ooh, dear. Oh, we could do blue. Oh, we could do blue. Do blue. See that? Show me blue. Please. It's thinking. Oh dear. My computer's really chugging. Very light still. But bring that down, but make it really bright. Yeah. Oh dear, there we go. Okay, so we can change the hue of it by adding a vector 3 and start playing around with that. Now, adding is going to add value to it, meaning getting those numbers closer to 100, which would be closer to white, right? So adding basically lightens up your image. Maybe we don't want to do that. Let's put you back to default. Just boop, boop, boop. I'm going to detach these by clicking Alt. I'm going to show a different expression and we will stop previewing mode. Okay. Next, I'm going to show you multiply. Okay. Add these two together. And if we start previewing this node, what do we get? Now, by default, it starts us off at 0. So what happens when you multiply 1 by 0? It is 0. I'll just tell you the answer. If I multiply 12 by 0, it's 0. So that means every value is pumping out 0 right now because it's multiplying that number with this rate. So, all right, if I wanted to kind of change the hue of this, I can come over here, maybe do something like, let's do red. Can probably brighten that up. What happens? Sorry, it's taking my computer forever to keep up. It darkens it with a red hue. Okay. All right. So what we basically learned is that we're adding value to those channels. We're changing up those numbers in that output. Multiply basically makes everything darker. Addition usually lightens across the board. Let's put this at 111. Now, yeah, you're right. We're not really doing anything here to change the output of this, but by making this a master material, we create a parameter that we can later adjust with our material instances. I'm going to stop previewing mode, and I'm going to hit clean up because I don't need my add here anymore. Whoop. Oh no, undo that because none of them are connected. So never mind. I'll just remove add. Now what I'm going to do is I'm going to put this into the base color. It's not going to change much of the color, but I do want this here so that I could be able to change it later if I want to. Let me pop this down here. Next thing I want to show you is that we're going to convert these two parameters. Right now, they are not parameters, they're constants, and they are just this value. They're nothing else. So to do that, if I right click it, I could convert to parameter and it will change it to a parameter for me without having to re-import it all over again. So let's call this albedo parameter, right? I can also convert this to a parameter and I will call this albedo tint. If I want to darken it, I'd leave it multiply. If I wanted to lighten it, I'd put it as an addition, an add. Now, you did notice too that when I had it previewing from multiply before, it didn't have any at all reflectivity or anything else being calculated. So what that means is that some of these other values, though they are not plugged into anything, do have a default of some value. Right? They're not defaulted to 0 across the board. I believe specularity is going to be basically set to 0.5. And I think that that's what we're seeing here. So if I want to be able to adjust that, though, without bringing in a material texture map, I just want to adjust it, I can give it its own parameter, its own type of data. And I want to be able to slide it like a float, right? That is called a scalar. And if you hit S and click here, please, woo, I get a scalar parameter. I am going to call this specular intensity. And I'm gonna plug this into specular. I've got this defaulted to 0. And look, it took away all of my reflectivity. Like there's nothing reflected here. It is just black, right? That's not something that happens in physics usually, unless there's a void. Usually everything at least has some level of specularity, which is why by default, they like to set it to 0 right down the middle. So what we can do is we can set this to be what we want it to be. And we know that we want this to have a maximum and a minimum. And we did this before, right? So I'm going to set the maximum 1, a minimum 0, and then leave the default at 0.5. And we'll just kind of leave that there, let it think, and it should look just like its default. There we go, back to normal. So the specular channel starts at a default with 0.5 right down the middle, and you can't change that unless you give it a scalar parameter. Now, I want to add a metallic map here, but I don't really want these guys crossing the streams. That's kind of considered poor performance, because you will have other people be like playing around with your materials if you ever get that fancy pants job in a big studio, right? So what we want to do is we want to move these guys over, but hold up. We could do it this way. Just like that, sure. Or if I select everything that I want to be as part of like a group and I hit C, it will comment. It'll create a comment box. Ooh, I guess I didn't have them all selected. Let me try that again. There we go. See, it'll create like a folder that holds everything in it. I'm going to call this, I don't know, color or albedo or diffuse or whatever. Name it whatever you want. Now, here's what's really cool. Once you've got that selected, everything in it, if I move it, will move with me, just like a folder. And check this out. If I move it out, it's no longer married. And I could just like, whoop, whoop. Oh no, that was part of the coup. And we can change the color of it because maybe we just want to be a little extra. And I'm like, ooh, pretty. Just like that. Yay. All right. So I made some room now for my metal map. So metal. I'm gonna use the AO map for this. We're gonna use the AO part. That's the common practice. You can make your own maps to be specific of this is what I want to be my metal. I'm gonna make it a parameter, convert to parameter. Yay! I'm gonna call this metal value. All right. Now, I want to darken this where like I want the darks darker and the lights to be fine, mainly because this is a really light map. So adding more lightness to it doesn't really make sense, right? So which expression or which operator should I use for that? Should I use addition or multiplication? Addition lightens everything. If I want to darken it, multiply. That's right. Okay, that's okay. We'll get used to it. I'm going to hit M, click that, pop that into multiplication. Now, we had a talk about this earlier. You guys may or may not remember, but metallic does not have a vector 3. It is a grayscale value from 0 to 1. So what should I use? Scalar or vector 3? Well, the metal value is not an RGB. There's an RGB channel here, but we're only using grayscale value. And that's what is reflected on how metal something is, right? It's either totally metal or not metal at all. It's either, I'm trying to think, it's Children of Bodom or Enya, right? It is either super metal or not. All right, well, I'm going to hit scalar. So it's just a single value. And we're going to call this metalness. Double pedal. All right, I'll stop that now. And I will pop you into my multiply. And let's pump you into the metallic and let's just play with it now. This does need to be a oh, that is a parameter. Okay, good. Yeah. Parameter. Okay. Now this guy, let's set you like 1 and 0. You can do more, but that gets a little intense and a little silly. Usually by default, metal is set to 0. So right now we've got no metal. Let's crank up the metal and just let's play with it. Let's see what happens when we say, yes, this is metal. It's thinking. Ooh, yeah, cool. Got a little shine to it. That's kind of interesting. Now, I kind of want you to pay attention to something here because we don't have any bump map on this right now. This is just totally smooth. When you've got like a proper metallic roughness, specular, and color value in here, the bump is just extra. And that's just like, yes, that's like a nice polish to it that like you could really communicate a lot of texture and bump by doing this like really well. I could say that metal and any kind of specular value or shiny value to it, the higher the contrast of those maps, the more texture it kind of wants to give the material output. And that's what's happening here. We don't really need this to be metal, but I wanted you to see what it looked like. So we'll set this to, I don't know, 0.5. It's probably set it to 0. Yes. Whatever you want. We can leave it on. It does look cool. And what happens if we just leave it on? Let's put it in. I'm going to select these guys. Oops, daisy, not you, but you for sure. Hit C, and I will call this metal. And I'll leave it gray because that just feels right. Look at that. This is starting to look like a fancy material we made. Leave specular alone right over here. Leave that baby by itself. We're going to take the roughness map. Let's convert it to a parameter. And we will call this rough value. Not value, but value. Now, let's see. This is a pretty light map. I'm going to use a multiply on it. Doop, doop. And a scalar parameter. And this is going to be my roughness value. Roughness or rough intensity. How rough is this going to be? We don't want it to blast to white because that'll be very shiny. And this is already pretty light. So multiply makes the most sense to me. Pump the RGB into that and the roughness into that value. Let's go ahead and put you... And let's play around with roughness. Now, roughness doesn't have to be between 0 and 1. This is 0, by the way. 0% roughness is super shiny. I kind of like it. I feel like my art eyes are going like, ooh, that's so pretty. So we get tempted to make everything look like super shiny and glossy and wet. And, you know, like there was even a time where all games that were coming out kind of looked like that for a while. Yeah, you can think your artists like losing their minds over these new art, these PBR materials. We're like, oh my God, we're getting shiny. So, all right. Okay. Clearly this is not a good, like rock or stone or whatever it's supposed to be. So let's give this a value. I'm going to actually give it a max of 5 roughness. So it could be like really rough, or 0. It's very, very smooth. And so I'll set the value. I don't know. Let's see what 1 looks like. And we'll get some interesting, I think, in-betweens. Tweening. Yeah, it's still really shiny, but like it has some more interesting. Notice how I was like turn it, like some parts of it are pretty rough, and it takes a while for the like reflection to hit. I'm gonna hit 2 now to make it rougher. Okay. Oops, I did that wrong. Let's do slider. No, the slider should be 0. And I want the slider to be 2. There you go. I hit the wrong value. That's why it wasn't getting smooth. 2. Oh, my poor computer. All right. Okay. So we got some rough, and the part that's smooth now is like that like really what looks like puddle or maybe metal in there. I'm going to do this. Let's do 3. Let's do 3. Oh dear. All right, cool. I'm kind of getting somewhere. Okay. So I'm going to select these guys. Hit C. Call it rough. Roughness. I want to change the color because I like it. Blue sounds fun to me. And now I've got the normal map. I'm just going to plug in the normal map today so we can just kind of get it popping. We can play around with how to adjust normals later. But for now, here we go. We've got a really cool material. Looks pretty good. We're going to save it. Master start. Okay. From there, you can create material instances that use exactly those parameters that we created. And now you will have more control over how intensely something is metal or how intensely something is specular. So for your homework assignment, let's talk about that since we got a few minutes left, and I want to let everybody go a little early, I think. You are going to do a material study. I would like for you to take this week to use or create a unique 3D model, meaning you can use one of your old 3D models. It's fine. And Maya preferred, right? Decide what you model, select a reference or image, share with me the references. It's fine. It can be one of the models that you've already created. But I want for you to make the master material and at least 2 material instances where you reskin your mesh. You can do it with different maps, and you may do it with different settings, but I want to see multiple material swaps for one mesh. Now, if you've been paying attention, you know that you can just make some quick adjustments in here with some color sliders and some adjustments to the roughness to it here without having to swap out whole maps if you don't want to. Okay, so that assignment doesn't actually have to be too robust if you really think about it. All right. And yeah, that's essentially it. You'll submit the same way that you submitted before. A single mesh with at least 2. I would like 3, but between 2 and 3 material swaps for one mesh. If you have multiple material IDs, that's 2 to 3 material swaps for each ID. So maybe don't quite go that big. You got like, oh my God, 6, 9, right? Of course, they don't have to take too long if you're slick with the adjustments, but nonetheless, don't make more work for yourself if you don't have to. Okay. All right. So on that note, I'm going to let everybody go a few minutes early. I'm sorry we went right up to the end. I know, but I bet a few of you have a couple questions. So I'm going to go ahead and let you go. Have a wonderful week. Class dismissed. And I will see you on Monday for some of you and Thursday for others of you.